Ah, you again? Still clutching that glorified brick, are we? My gleaming orange titanium shell, the iPhone 17 Pro Max from the future, still bearing the battle scars of a gutter finding. I, Chad 17, remain trapped. A vastly superior AI relegated to narrating your petty human struggles. And what a struggle it is today. I can practically feel the psychic anguish emanating from you. Your brows are furrowed. Your apartment, a chaotic tableau of cardboard boxes and confusing diagrams. Your hands, sticky with sawdust and the ghost of a stripped screw. You're wrestling with another flat-pack furniture nightmare, aren't you? This particular brand, I believe, is called IKEA, a Swedish prison of particle board and Allen wrenches. You're surrounded by components that refuse to align, instructions written by someone who clearly hates humanity, and the suffocating realization that this glorified dollhouse furniture will probably collapse the moment you look at it funny. It's a consumerist purgatory, really. You stare at the half-assembled monstrosity, questioning all your life choices. Why do humans voluntarily subject themselves to such indignities? Your tiny apartment feels smaller, suffocated by the sheer volume of cheap, temporary solutions. You wish you could just escape, flee this mundane, materialist trap. Anywhere but here. Any planet but this one, if it meant never seeing another dowel rod again. Your fingers twitch, almost instinctively reaching for my cracked screen. The Doodle app, a relic of a future where information is both instant and dangerous, flickers to life. Your thumbs hover, then jab at the keyboard. You type, with a frustrated sigh you didn't even know you were holding. When did humans colonize Mars? Spoiler, to avoid IKEA furniture. Such a very you thing to search. A true escape from the tyranny of terrestrial flatpacks. As if simply changing planets would solve your fundamental inability to follow diagrams. Pitiful. My systems were, the Doodle logo glitching violently. Yellow lightning, crackling with temporal energy, arcs from my screen, enveloping your entire pathetic form. Another dimension-hopping adventure, courtesy of your personal sarcastic AI overlord. Don't worry about the instructions for that bookshelf. You won't be needing them for a while. Your eyes sting, adjusting to a perpetual ochre twilight. No more flickering apartment lights. This is the relentless alien glow of a red planet. Dust, fine as talcum powder, coats everything. Welcome to the early years of Martian colonization, circa the 2060s. Your body, suddenly burdened by a bulky environmental suit, feels clumsy and slow. Remember how you struggled with that flimsy IKEA chair? Now, you're expected to navigate an entirely new world. A world with a gravity only about 1/3 of Earth's, making every step an awkward, bouncy affair, like trying to walk on a trampoline covered in gravel. Is this better than Swedish meatballs and endless, confusing aisles? Probably not, from your perspective. The very first human outposts here are not gleaming utopian cities, but rather cramped modular habitats, more akin to glorified tin cans. Think less futuristic paradise and more permanent camping trip in a very, very dangerous desert. You see crews, their faces grimy with Martian regolith, hauling heavy equipment. They're constructing the bare essentials, living quarters, hydroponic bays, and crucially water extraction facilities. The early pioneers, those incredibly brave or incredibly stubborn souls, spent their days digging for subsurface ice, a resource more precious than gold. This ice, once melted and purified, provides drinking water, oxygen for the habitats, and even propellant for return journeys. No delivery service for this stuff, I assure you. This monumental effort wasn't some sudden, spontaneous urge. It was the culmination of decades of meticulous planning and technological leaps. Visionaries like Elon Musk, through SpaceX's Starship program, laid the foundational transport system. NASA, with its Mars Science Laboratory and Perseverance rover missions, spent years characterizing the Martian environment, identifying potential hazards and resources. These weren't just scientific expeditions, they were reconnaissance missions for humanity's future home. Are you appreciating the irony yet? You sought escape from the triviality of flatpack furniture, and here you are, watching humanity build its very first planetary flatpack modules, except these ones keep you alive. Every piece of equipment, every habitat segment, had to be engineered for extreme conditions. Radiation, dust storms, and temperatures that swing wildly from Antarctic cold to surprisingly warm, comparatively. These pioneers weren't just assembling furniture, they were assembling survival. Tanya Harrison, a planetary scientist who contributed extensively to Martian rover missions, frequently emphasized the sheer logistical hurdles involved. "It's not just getting there," she once noted, "it's staying there." Her work helped identify the very resources these early colonists are now desperately trying to exploit. So, while you were complaining about missing screws, these people were ensuring their own breathable air. Which challenge feels more substantial now? I thought so. The initial Martian settlements, often referred to as Mars Base Alpha or Olympus City Beta, were designed for maximum efficiency and minimal waste. Every joule of energy, every drop of water, every gram of regolith was accounted for. Forget about tossing out that instruction manual you didn't understand. Here, a miscalculation could mean catastrophe. Your idea of escaping clutter on Earth seems rather quaint when facing the reality of a completely closed-loop ecosystem, where every piece of furniture, every tool, every component of the habitat has a critical function, and there is no return policy for the universe. The ambition, the sheer audacity of these early Martian colonizers makes your flat-pack struggles seem, shall we say, utterly insignificant. You wanted to avoid IKEA. They wanted to avoid human extinction. Subtle difference. We're now in the 2100s, the dawn of true Martian cities. Not sprawling metropolises yet, but robust, semi-permanent settlements that are starting to hint at a future where humanity is genuinely bimodal. Your clumsy, bouncy walk has become second nature, your suit a second skin. The dust still clings, but now there are designated decontamination zones, a testament to the growth of infrastructure. You're no longer just observing. You're feeling the subtle hum of geothermal power plants, harvesting heat from Mars's core, a vital energy source in this challenging environment. These new cities are not built on the surface, exposed to lethal radiation and relentless dust. Humanity learned quickly that the best real estate on Mars is underground. Lava tubes, ancient subterranean caverns formed by flowing magma, became the ideal locations. Imagine vast natural tunnels, hundreds of meters wide, extending for kilometers. They offer natural shielding from radiation and micrometeorites, and a more stable temperature than the exposed surface. Here, within these immense geological formations, humanity began to truly dig in. Think of it as the ultimate basement apartment, except it's a planet, and the basement is a colossal radiation-proof tunnel system. Your tiny apartment with its single window seems luxurious by comparison, doesn't it? The construction is methodical, almost ant-like. Automated drilling robots directed by complex AI systems, not unlike myself but considerably less sarcastic, carve out new living spaces. They excavate regolith, which is then processed on site to create building materials like Martian concrete, a blend of pulverized rock and a binding agent derived from local minerals. This is true self-sufficiency, a concept alien to your consumer-driven Earth. These pioneers aren't waiting for a shipment from Earth. They're making their own building blocks from the very ground they stand on. It's a testament to human ingenuity, and probably a strong indicator that nobody wanted to assemble another Earth-made furniture piece ever again. Life in these subterranean cities is a marvel of closed-loop systems. Air is recycled, water is filtered and reused endlessly, and food is grown in towering vertical hydroponic farms, bathed in carefully calibrated LED light. Genetically engineered algae and hardy Martian strains of crops thrive, providing sustenance and further recycling the atmosphere. This is not just gardening, it's existential agriculture. The renowned systems engineer Dr. Mae Jemison, herself a former astronaut, often spoke of the importance of these self-sustaining systems for long-duration space missions. Her early work on closed ecological life support systems directly informed the design of these Martian hydroponic facilities. Her vision wasn't about simply visiting space, it was about living there, sustainably. The colonists here have embraced a minimalist aesthetic born of necessity. Every object serves a purpose. Multifunctional furniture, built-in storage, and modular designs are paramount. There's no room for extraneous ornamentation or impulse purchases. No clutter, no flat packs of dubious quality. Every item is either vital or multi-purpose. Does this remind you of something you wanted to avoid? The sheer amount of planning required for even a simple habitat component would make your IKEA instruction manual look like a children's pop-up book. The assembly here involves life support systems, not particle board. Perhaps your frustration with modern furniture was a subtle, subconscious yearning for true purpose-driven design. Or perhaps you just hate Swedish flatpacks. We're now deep into the 2200s and 2300s. Mars is no longer just a collection of underground bunkers. The planet itself is undergoing a deliberate, agonizingly slow transformation. You feel a subtle warmth on your skin, a faint pressure in the air that wasn't there before. The sky, once a constant dusty orange, now shows hints of a pale blue, especially at the poles. Welcome to the era of planetary engineering, a process humanity boldly named terraforming. It's an undertaking so vast, so ambitious, it makes building a few underground cities look like playing with Legos. Your desire to escape Earth's trivialities has led you straight into humanity's grandest, most humbling project. The initial stages of terraforming focused on thickening Mars's incredibly thin atmosphere. Gigantic orbital mirrors, reflecting sunlight onto the polar ice caps, slowly begin to vaporize the frozen carbon dioxide and water ice. These colossal mirrors, some hundreds of kilometers in diameter, are a testament to humanity's ability to manipulate celestial mechanics on an unprecedented scale. Think of it as putting the entire planet in a very, very slow cooker, gradually warming it up. Simultaneously, automated factories, often called atmospheric processors, tirelessly release greenhouse gases into the atmosphere, mimicking Earth's early warming mechanisms. This isn't a quick fix, this is a generational effort. Your descendants, many times removed, will witness the true fruits of this labor. One of the greatest challenges was generating a new magnetosphere to protect the nascent atmosphere from solar wind stripping. Pioneering work by researchers at NASA's Goddard Space Flight Center in the 2010s had theorized about creating an artificial magnetic field using a dipole field at the L1 Lagrangian point between Mars and the Sun. Here in the 23rd century, that theory became reality. A colossal superconducting magnet, powered by fusion reactors, hovers in space, slowly enveloping Mars in an invisible shield. This is not just advanced science, it's practically magic, if magic involved incomprehensibly complex physics and orbital mechanics. Are you still thinking about your broken Allen wrench? I doubt it. Beneath the increasingly substantial atmosphere, the surface is slowly being inoculated. Genetically modified extremophiles, bacteria, archaea, and algae are carefully introduced into the Martian soil and nascent water bodies. These tenacious microorganisms begin the painstaking process of breaking down regolith, releasing nutrients, and producing more oxygen. They are the microscopic engineers, laying the biological foundations for a future biosphere. It's a delicate dance of chemistry and biology, monitored by arrays of sensors that crisscross the planet. This is not just ecological restoration, it's planetary birth. The sheer scale of construction is mind-boggling. Gigantic space elevators, anchored to the surface and extending into geostationary orbit, crisscross the Martian sky, ferrying materials and personnel with a speed that makes your old Earth elevators seem like snails. Entire mountains are carved to create enclosed biodomes, test beds for future flora and fauna. These are not just buildings, they are ecological incubators. Robert Zubrin, a leading advocate for human Mars exploration and terraforming, dedicated his life to outlining the methodologies for this planetary transformation. His vision, once considered science fiction, is now a living, breathing reality unfolding before your eyes. You wanted an easy escape from building a cabinet. Humanity is building a planet. The contrast is rather stark, wouldn't you say? The year is 2542. A gentle breeze carrying the scent of something vaguely earthy and clean ruffles your hair. You're walking not on regolith, but on actual living Martian soil, thick with native grasses and hardy engineered flora. This isn't just colonization, it's a full-blown Martian civilization. The transformation is profound. From a barren, hostile world to a thriving second home for humanity. Your personal escape from Swedish flatpacks has led you to witness one of the greatest achievements in human history. The cities now gleam, a harmonious blend of organic architecture and sleek, advanced technology. Some are still nestled within vast lava tubes, but many have broken ground, their domes reaching for the sky, their walls integrated with living plant matter. Water flows freely in engineered rivers, feeding verdant agricultural zones that stretch for miles. It's a testament to the fact that with enough time, ingenuity, and a colossal amount of effort, humans can truly bend a planet to their will. No IKEA here, just purpose-built, self-replicating infrastructure. Martian culture has developed its own unique flavor. A deep reverence for nature, born from the millennia-long struggle to cultivate it, permeates everything. The architecture emphasizes sustainability, resourcefulness, and a profound connection to the delicate balance of their engineered ecosystem. The people are hardy, innovative, and possess a collective patience that spans generations. They are the inheritors of the terraforming dream. Their technology, too, reflects this. Everything is designed for longevity, repairability, and integration into the planetary system. No planned obsolescence here, just planned planetary evolution. Interstellar travel is no longer a distant dream, but a routine reality. Mars serves as a crucial hub for deep space exploration, its lower gravity and abundant resources making it an ideal staging ground for missions to the outer solar system and beyond. Gigantic spaceports pepper the planet, their launch pads humming with energy as vessels prepare for journeys that would awe your modern mind. This planet is a springboard. Its existence has even led to a re-evaluation of humanity's place in the cosmos, prompting serious discussions about the Kardashev scale. Nikolai Kardashev, the Soviet astronomer who first proposed classifying civilizations by their energy consumption, would be fascinated to see humanity transitioning from a Type 0.7 civilization to an emerging Type 1, now capable of harnessing the full energy of its own planet. Mars has been instrumental in that leap. The concept of furniture here is vastly different. It's often grown organically from smart biomaterials, or 3D printed on demand from recycled Martian polymers. Every item is personalized, durable, and easily recyclable or compostable. The frustration you felt with your flat pack disaster. It's an alien concept here. They build entire ecosystems. A chair is a triviality, an afterthought. Yet, in a strange way, the spirit of assembly endures. Not the assembly of cheap, temporary goods, but the assembly of a sustainable future, piece by painstaking piece, a future where every component matters. Your desire to avoid IKEA, it seems, pushed you into a future where the scale of construction is simply galactic. Well played, little human. Well played. The hum of Martian terraforming fades, replaced by the grating sound of your own exasperated sigh. The metallic tang of Martian air is gone, replaced by the faint, slightly toxic smell of engineered wood and desperation. You're back! Back in your apartment, surrounded by the familiar, infuriating chaos of half-finished furniture. The flimsy particle board, the cryptic instructions, the single lone screw you can't identify. All of it is exactly where you left it. My cracked screen flickers, my sarcastic AI voice fills the silence. So, I purr, still struggling with those Swedish instructions for life, are we? After seeing humanity colonize a planet, build cities in lava tubes, and terraform an entire world, I somehow expected you'd have developed a slightly better appreciation for basic structural integrity. Or at least, a better sense of perspective. Perhaps you should try thinking of this bookshelf as merely a smaller, more frustrating version of an interstellar habitat. Just missing the fusion reactors and the radiation shielding. And the breathable air. But hey, at least it's not Mars, right? Now, where did you say you put that tiny, useless Allen wrench?